I'm going to attempt to start these notes a third time. Oh, look, Lexi wants back in. Okay, there, she's in, I think. All right, so this deal right here is telling you that you are dealing with a normal distribution. Your variable x is distributed as a normal distribution with a mean of 10 and standard deviation of 2.3. This is the generic setup. X squiggle in mu sigma squared. All right. We are trying to find the probability that a randomly selected object falls between the values 8 and 11 when our mean is 10 and our standard deviation is 3, and we've been asked to illustrate the results. I'm starting by illustrating the results because, well, that'll usually get you a method mark. So what we got? We got 11, which is on this side, and we're coming down to 8 on this side. Now, neither one of these is a pretty amount of standard deviations away from mean. I mean, our standard deviation is 2.3. So without a probability table of some sort, we can't find how much of the curve is covered up by that shaded region without the aid of technology. But I can tell you how to set this up. Our calculators, all of our calculators, have the ability to go left. Some of the newer versions of the operating system can go to the right and go to the center. But I have to teach as if we all have the old one because some of us do. So what we're going to do is say, for the sake of my notes, we're going to say our calculators can only go to the left. So if I was trying to find just that purple shaded region, what I would need to do on my calculator is I would need to find the probability that x is less than or equal to 11 and subtract the probability that x is less than or equal to 8. And that would leave behind the space between 8 and 11. Before I go to the calculator, I do want to mention something. When you are doing continuous variables, which is what the normal distribution represents, continuous variables, it does not matter if you say less than 11 or less than or equal to 11. They represent the same thing. It matters when you're talking about discrete, because if you say less than 11, you're specifically starting at the number 10. If I say less than 11 in continuous variables, how far less than 10? Is it 11, is it like 10.9? What about 10.99? What about 10.999? You see, because it's a continuous variable, there is no definition of less than 11, which means every time you draw the vertical line there, I'm going to draw it as dotted, you could either write less than or less than or equal to. Completely the same thing. Don't stress out about it. Cool? Okay. We only use one command for finding probabilities on a normal distribution on our calculator. We were using two different commands for binomial distributions. There's a reason why. For binomial distributions, you could find the probability that x equals 11, or you could find the probability that x is less than or equal to 11. X is equal to 11 on a binomial distribution was binomial PDF. X is less than or equal to 11 on a binomial distribution is binomial CDF, because the C means cumulative. It added up all the probabilities from 0 to 11. Normal distributions, we are only going to use CDF. So it's located in the same spot in distributions. So second vars, normal CDF will be command 2. And you hit enter. Lower bound. Lower bound is asking you, how far down should you go? Well, that is -1 times 10 to the 99. It's essentially saying 0. Now you can't ever get to 0, but that says, oh, I want you to go as close to 0, which is extremely left of any mean, goes close to 0 as possible. So you can just leave that alone. Now, your upper bound. Your upper bound is, oh, you can't see the notes. I turned around and pointed at them. The upper bound was the 11, because remember, we're doing the probability of 11 minus the probability of 8. So our upper bound will be 11. Your mean is not 0. You see it defaulted to 0. Your mean was 10, and your sigma is 2.3. and then you just hit paste. And I'm going to hit enter one more time.
So,
Now hold on. Now, what this told you is that 66.8% of the data is found to the left of x equals 11. But you need to figure out how much is between 8 and 11. So we need to subtract all the data that's to the left of 8. So I'm just going to hit minus and then second vars again and do normal CDF again. And all we have to change is the upper bound. Now the upper bound is 8 because the calculator is always going left. Okay? So I'm going to hit enter a few times. It now has the first normal CDF minus the second normal CDF, and it's going to tell me that about 0.476 is the probability of finding something between those two numbers. 0.4763 standard, 3 sig figs.
can I ask now?
0.476. Gavin, do you have a question?
So, is it always going to be the one that's to the right of the mean minus the one to the left?
Well, if you're trying to find between two numbers, it's always going to be the right one minus the left one. Like if I said how much space is there between the numbers 15 and 10, wouldn't you do 15 minus 10?
Yeah.
There you go. It's always going to be right minus left. It doesn't even matter if it's on the right side of the mean or not. If you're trying to find the probability that something landed between two values, it's always going to be right minus left. Always. Okay? Good?
Yes.
Yes?
I did not get that.
You did not get that.
No. I got the first number and then the second one
Did you do answer minus? Well, bring me your calculator. Let me see. Pause the video. All right. Crisis averted. Part B. This time we're going to be finding the probability that an object is to the left of 12. Again, you'd be surprised how often drawing the shape is going to get you a method mark. So this is part B. I'm just going to draw a bell curve to the best of my ability. It's not very good ability, but to the best of my ability. I had to go so slow with this lagging computer. There's 10, and 12 is somewhere over here. And we're legitimately trying to figure out how much space does this cover. That's it. There is absolutely no work to show for this. You draw that picture on your test, and then you write the probability that x is less than or equal to 12 equals, and you just grab a calculator. What that means is if you don't draw that image and your answer is wrong, you just lost all the marks. And it'll probably be a 3-mark question, to be honest with you. I don't know why 3, it just normally is. I'm just going to go, since our mean and standard deviation are the same, I'm just going to go to second distribution, normal CDF. Now my upper bound is 12. Nothing else has changed. And I'll take my answer now. There you go. About 0.808. 80% of the data. Wow. About 0.808.
And
Yeah, what's up?
if it was like x is just less than 12, would it be the other one?
No. No. If it said less than 12, it would be the exact same answer. Because we're doing continuous variables, if you say less than 12, then how close to 12 are you going? There's no such thing as how close can I get. You can get infinitely close to 12. Because I can't find just the probability that x is 12. It doesn't work like that. Normal distributions are all about how much data is to the left of a value.
So it doesn't matter.
Yeah, it doesn't matter if it says equal to or not. See, this next one says probability x is greater than 9. It could have said greater than or equal to 9. It doesn't make a difference. It's the same answer. And I'm going to, how much space do I have? Do I have vertical space? I have vertical space, so I'm going to do mine right down here. So here's part C. Our picture. And we're trying to go greater than 9. I probably should get closer to that x-axis, huh? whatever. You get the idea. So here's our 10. Our 9 is actually to the left of our mean. And we've been asked to find this. But your calculator can only go left. So what are you going to do? 1 minus. So you would write a complement. So you'd write the probability that x is greater than 9 is equal to 1 minus the probability that x is less than or equal to 9. Or you could just write less than 9. It doesn't matter. It's the same answer. And then again, you go to the technology. And I'm going to start with 1 minus. 1 minus, and then second bars, normal CDF. Now my upper bound is a 9. And I just paste. Ta-da! 0.668. And you know that answer is reasonable because how much data is to the right of 10? 50%. 0.5 is to the right of 10. So you expect bigger than 0.5 to be the right of 9. That's how you know your answer is reasonable. About 0.668. Yes, Vivian.
So why did you do the 1 minus the probability of that?
Because your calculator can only go left. Your calculator can only calculate this probability. And since the orange and the pink add up to 1, I go, fine, if I want the pink, I'll just do 1, the whole thing, minus the orange piece. And I'll be left with just the pink piece.
Then why would you do that for 9?
Because, Gavin, your calculator can only calculate probabilities to the left of a number, but greater than is to the right of a number. The lag is real. Oh my goodness. If I could close any other programs, I absolutely would. In 1972, the heights of rugby players were approximately normally distributed with mean 179 and standard deviation 7. X is distributed normally with mean 179 and standard deviation 7. And if you don't write the little exponent of 2, you're not going to get that mark. That's always going to be sigma squared written right there, always. Find the probability that a randomly selected player is at least 175. So for part A, you're talking about the probability that x is greater than or equal to 175. Again, that is to the right. Your calculator cannot go right. If you want to draw that shape, you can, but you don't have to. I know this says to the right, and I know my calculator can't do that because I don't have a TI Inspire, which, by the way, it can go right. I know that this is equal to 1 minus the probability of x being less than 175. And to the technology, we go. Just going to clear this. There's a lot of stuff on the screen. 1 minus second vars normal CDF. Lower bound, sure. Upper bound, 179. The mean, well, wait, no, sorry. Upper bound was, what's 175, thank you. The mean is 179, and the standard deviation is 7. And we hit paste. I'll take it now. There we go. 0.716. Again, it's a reasonable number. You expect it to be bigger than 0.5 because the value that we were talking about, 175, is to the left of mean. Forgot the number already. 0.716. There. Part B, between two values, 170 and 190. to write painfully slow just so it's not jagged. The calculator can only go left. So what we're going to have to do is figure out the probability that x is smaller than 190 and then get rid of the space to the left of 170. If that's confusing, let me draw the picture for you. Mean was here in the middle. 190 is here-ish. Picture not drawn to scale. And 170, I don't know, I'm just going crazy here, is over here. In order for me to get the space in between them, I will have to find everything to the left of 190, and then I'll have to get rid of the stuff that is to the left of 170. So this is the probability that x is less than 190 minus the probability that x is less than 170. Of course, I don't know this number, so to the tech we go. Probability that we are less than, was it 190? 190, nothing else changed, minus probability that we are less than 170. .843. 0.843. There you go. Normal distributions. Do you have any questions on it before I go to the back side of the notes? Having to write this slow is making me slow down the way I teach, and it is painful. I feel like I hit next, I feel like I should eat a sandwich afterwards, it takes so long. There we go, okay. The time taken by students to complete a puzzle is normally distributed with mean 28.3 minutes and standard deviation 3.6 minutes. Calculate the probability that stuff is happening. So x is distributed normally with mean of 28.3 and standard deviation 3.6. So you have to say 3.6 squared because it's showing you the variance. We're trying to figure out the probability that a randomly selected student took at least 30 minutes. The probability, the probability that x is greater than or equal to 30. Again, calculator can't go right. Gotta go left. So this is A. Writing so slow. 1 minus the probability of less than 30. .3 and 3.6. 28.3 and 3.6. 1 minus second bars. 20. Oh wait, what's the number I'm looking for? 30?
Yeah.
Mean is, what is it? 28.6? 0.3, goodness, and 3.6, thank you. Too much to memorize. 0.318. 0.318. Part B. Ooh, okay, there it is. Part B. Out of 10 randomly selected students, at most, half of them took at least 30 minutes. Whose brain just popped? Julia?
Say what?
Oh, I thought you were telling me what I should do.
Oh, no, I said my brain popped.
Your brain popped.
Okay, wait, can I just say one thing?
Sure you can.
Alright, well, what I would think of to do first is, like, I would think of, like, the expected, like, since we have, like, probability that, like, they gave us a first, or what we needed in part, or, like, in part A for part B. But
Well, they gave you the probability that a single student would
yeah,
take at least 30 minutes. Okay.
so, I understand, like, out of 10, like, if it stopped out of 10 randomly selected students, then be like, oh, then you find, like, the expected. But I don't know how to.
No, because it says at most of them. If it said how many would you expect,
Yeah,
you would expect 3.18 of them.
uh-huh.
But it says at most half of them. What does this sound like? Oh, it's binomial. Oh, it's binomial. Okay, so for part B, let's let capital Y be the number, this is painful, of students. I feel like I should type this instead of trying to write it. Holy cow. So if capital Y is the number of students that took at least 30 minutes, what we know is that capital Y is distributed binomially because a student either did or did not take at least 30 minutes, with the number of trials being 10 and the probability of success being 0.318. We have been asked to find the probability that at most half of them took at least 30. So this is a binomial CDF with their x value being 5. No, because binomial CDFs go left. So we can go, less than means go left. So we go to our calculator, and we go to second, vars, and we scroll all the way down to binom CDF because we're adding up 0 through 5. The number of trials is 10. The probability of success is the probability a student took at least 30 minutes, or what was it, 318? Thank you. And the x value we're looking for is 5 or less. 0.938. Wow. That is a lot. So what did we just do? We just used a normal distribution to find the probability of a binomial event. Wow, look how IB likes to mix materials. So in order to be successful on the next unit test, you must be successful with the last material as well. It's crazy how math builds upon itself, huh? Before we move on, is that it or is there another one? That's it, okay. So before I stop the video, I really feel like there should be some questions out there.
About?
Ah, yes.
So how did you know that it was binomial?
How did I recognize binomial? Okay, that's the perfect question. How do we recognize a binomial situation? You were told you're taking more than one person. That basically screams binomial. Because all the other things, did you ever notice all the other ones were like, what's the probability that a randomly selected thing was between this and this? The moment you take more than one and you start trying to compare the probabilities of different things happening, that's binomial. An event either happens or does not. So we said, okay, find the probability that a student takes at least 30 minutes. Boom. They go, now I took 10 kids. What's the probability 0 or 1 or 2 or 3 or 4 or 5 of them met the criteria? Someone either meets the criteria or does not. So it just jumps out at you as binomial because you took more than one individual. And by the way, expect conditional probabilities to also be blended into this material. Given that at most 5, yada, 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 okay? So you can expect these kinds of questions to begin with normal distribution, halfway through become binomial distribution, and then end with conditional probabilities. That is a number 9 IB probability question.
I no longer like this set of units.
You haven't even seen the end of this unit yet. This unit is still easy. It has not gotten hard yet. Any other questions other than how did I recognize binomial? Because that's the big one. How did I recognize binomial? Like Gavin wants to ask a question, but he has no clue what that question should be.
Yeah.
Well, here's the thing. You tell me. What did you not understand that I did? See, that's not a question. You're just telling me,
Scroll down.
at what point did you stop understanding?
Can you scroll down?
Can I scroll down? Sure.
I kind of my thought process is going.
That's all of it right there.
So that B is the beginning part, right?
The capital B, no, B means this is distributed binomially. This is a normal distribution. This is a binomial distribution. And that's why I had to use a different variable. I couldn't say X was distributed as a binomial because it was not.
10 is the amount.
10 was number of trials. And you were looking for 5 or less, which means any 5 or 4 or 3 or 2 or 1 or 0 all satisfied. So you have to find the probability of all 6 of those things and add them up. And that's why we chose CDF, because it added up all 6 probabilities for us.
Instead of that. So that's 1 on the calculator instead of 2.
No, at the very top. Okay, how about this? We do not use, listen, you're not looking. We do not use normal PDF in this program.
Oh.
We only use normal CDF,
Never.
but we do binomial PDF and binomial CDF. We do both binomials. This question could have been binomial PDF. It could have said 10 students are chosen at random. What's the probability exactly 4 of them take at least 30 minutes? That would have been binom PDF and X equals 4. Okay, so if I say exactly a single amount, it's PDF for binom. If I say at least or at most, it's CDF for binom. Okay?
What would a normal PDF question be?
Normal PDF, I'm going to be honest with you, I don't know. I've asked this question, I've looked it up before, and I still don't remember because I've never taught it. I can't remember what normal PDF does.
Because it would be an exact number.
Yeah, it has use. I just don't know what because I haven't studied enough statistics, I'm sorry. And now that I don't sound like I know what I'm doing, it's time for me to stop the video.